So you know how we ask our AI assistants for like simple facts all the time? It's second nature now. But what happens when you ask it something really complicated? Something that requires actual, deep research? Well, that's where things get interesting. That is the next great frontier for AI, and it turns out a brand new framework might just be showing us the way.
All right, here's what we're going to cover. First, we'll talk about the big research gap in AI right now. Then, we'll get into what deep research even is. After that, we'll look at this cool new system, InfoSeek, that's built to teach it. And of course, we'll talk out the pretty amazing results and, why all of this really matters.
Okay, so let's get right to the problem. We all know LLMs are incredible at pulling up simple facts, right? But they kind of hit a wall when you throw something truly complex at them. This is the next major challenge, and the researchers behind this paper have a name for it: deep research.
I mean, think about it for a second. Have you ever tried asking an AI one of those multi-layered questions? The kind that needs to connect a bunch of different dots. And what you get back is just confusing, or maybe it's just plain wrong. Yeah, there's a really fundamental reason why that happens, and it all boils down to their training.
The core issue, really, is that the AI's training wheels are kind of still on. These huge data sets they're trained on, you might have heard of them, like natural questions or hot pot QA, they're basically just massive lists of simple questions and answers. And look, they're great for teaching a basic lookup skill, but they just don't have the kind of structural depth you need to teach an AI how to juggle multiple pieces of evidence, how to use logic, the stuff that's at the very heart of real research.
So, if we're going to solve this, we first need to get super clear on what actually makes a research question hard for an AI. And it's not just about adding more steps, like a longer to-do list. No, it's about combining different kinds of complexity. And they build on each other in this really fascinating way.
Okay, first up, you've got something called a constraint satisfaction problem, a CSP. The easiest way to think about this is like a Venn diagram. You have a bunch of separate, independent facts. So in this example, born in London, and graduated from Cambridge, and got a PhD from Princeton. The answer has to be the one thing, in this case the person, Alan Turing, that sits right in the middle in that tiny little intersection of all those facts.
All right, next, we have the multi-hop problem. This one is different. It's not about a bunch of parallel facts. It's a chain, a sequence of logical steps. To get the answer, you have to follow the breadcrumbs. So, step 1, who solved the Enigma code? That's Alan Turing. Okay, step 2, where was he born? London. And step 3, what country is London the capital of? England. See, every single step depends on the answer you got right before it.
Now here's where it gets really interesting. What happens when you smash those two ideas together? Well, you get what's called a hierarchical constraint satisfaction problem, or HCSP. And this, right here, is the essence of deep research. It's a multi-hop problem, but each hop in the chain isn't just a simple fact. Each hop is its own complex constraint satisfaction problem that has to be solved first. This is the mountaintop, and this is exactly where today's AI just breaks down.
So, if the problem is that we don't have complex enough training data, well, the solution seems pretty obvious, right? We have to make it. And that is precisely what this new InfoSeek framework was built for. Its whole job is to automatically create these insanely difficult hierarchical questions and to do it at a massive scale.
And this is where the genius of this approach really shines through. See, InfoSeek isn't just another dataset, like a big static list of questions. No, it's a dynamic system. It actually uses two different AI agents that call them a planner and a browser that work as a team to build these complex research trees. It's basically mimicking the exact process a human researcher would go through, piecing things together online.
So here's a quick look at how it actually works. First, the planner agent starts at the end. It picks a final answer. Let's just use Alan Turing again. Then the browser agent comes in and sort of blurs that answer. It finds a whole set of facts that, together, uniquely point to Turing. That's our mini CSP right there. Then the planner jumps back in to extend the tree, adding another layer, which creates that multi-hop link. And this whole back and forth just repeats until the question hits a target complexity level. And only then is the whole thing converted into a normal, natural language question.
So when you put them side by side, the difference is just night and day. The old data sets, they were stuck with those simpler multi-hop problems, and they were really hard to scale up. But the InfoSeek dataset, it's purpose-built to create these true, gnarly hierarchical problems. You can actually dial the complexity up or down, and it's already churned out over 50,000 of these things.
Okay, so we've got this awesome new way to generate super hard questions. But the real question is, does it actually work? Does training on this stuff make a difference?
Well, this is where the story gets really good. We're about to see a classic underdog story, a much smaller AI model that learned to punch way above its weight.
So first, just how hard are we talking? Well, when the researchers took a very powerful 72 billion parameter model and threw it at the InfoSeek dataset, it failed. A lot. We're talking a 91.6% failure rate. That's staggering. This isn't just a small step up in difficulty, it's a quantum leap. It really exposes the huge reasoning gaps that exist even in some of our strongest models today.
And now for the big reveal. The researchers took their new data set and used it to train a pretty small model, just 3 billion parameters, and they called it InfoSeeker. So they put it to the test, and it didn't just do okay, it did amazing. Get this little 3B model actually beat a model 10 times its size, a 32 billion parameter giant. And it even managed to squeak past a major commercial API. Incredible.
Yeah, this table really tells the whole story. Just look at those numbers. The 3 billion parameter InfoSeeker is right there, neck and neck, competing directly with a heavyweight like Gemini 2.5 Pro. It's just absolute proof of something really important. The quality and the structure of your training data can matter even more than the raw size of your model. It's all about training smarter, not just bigger.
Okay, so a smaller model learned how to be a better researcher. That's super cool, but what does it all mean? What are the big picture implications here? Well, this is about way more than just better answers. It's about changing the fundamental mission of these AI systems.
And I think this quote from the paper just says it perfectly. We're talking about a shift. The goal is to move beyond AIs that are just conversational assistants, things that chat with you. The future is about creating autonomous knowledge engines, systems that can go out, find information, pull it all together, and actually reason about it, all on their own.
And when you start thinking about the potential applications, wow, they are huge. Just imagine an AI that could speed up scientific discovery by finding hidden connections between thousands of research papers. Or one that could do a deep, complex analysis of government policy. This is the kind of leap in capability we need to build AI agents that are truly capable and reliable, and that could completely change how we interact with information.
So, when you boil it all down, here's the bottom line. We're on the cusp of teaching AI not just to know things, but how to find out new things. And that brings me to the final question I really want to leave you with. Once we have AI that can truly perform this kind of deep, complex research for us, what problems that seem unsolvable today might we finally be able to crack?